Hello friends, welcome to my channel. Let's have a look at problem 416, Partition Equal Subset Sum. So this problem actually in essence is the same as today's challenge problem, Leetcode 473. So as such, we're going to share a solution parallel to the solution video for Leetcode 473. So actually for this problem, which is a classical problem, the following methods are available. For example, backtracking or traversal. This is the method we are going to share in this video. And also we can produce the possible numbers and use set abstract data structure to check. Or we can regard this problem as a 0-1 knapsack problem. So with that said, I'll directly go to the code. Notice that we want to partition the whole array to be two parts. Therefore, each element in the nums array is either in this part or in the other part. It must be one of the two cases. So this actually determines the call recursion call pattern. So exactly similar as the solution we provide for Leetcode 473. So now let's go to the procedure. First, I'm going to track the information for length and the sum. So I'm going to use the total, so which is the length of nums and the sum of nums. So in order that we can partition the array into two parts with equal sum, the first necessary condition is that the total is an even number, right? So this is a case we should keep in mind. So now we're going to write a partition function, so which we are going to use memorization. So for that, we're going to define the function as partition, same name as in problem 473. So here we are partitioning two parts, so I'll use L1, L2, and I. So here L1, L2 is separate sums, and I is the current index we are looking at, right? So the return type is going to be a Boolean. So with that said, because in the process we may use recursion call, so here I'm going to use a cache decorator. So with that said, let's do the same thing as in Leetcode 473. First is going to check the return condition if L1 equals L2 equals total over 2. So then let me use a variable. Let's see, go equals total over 2. So let's see. Let's directly use that. It's okay. So total over 2. So if this is the case, we're going to return true. So this is the one case. In another case, if I is out of bound, so we're going to return false. So another case is that if L1 is greater than total over 2, or L2 is greater than total over 2. In this case, we're going to return false. Otherwise, we're going to make recursion call. So partition corresponding to add the current number nums I to the first sum or to the second sum. So let's add to the first sum, that is nums I, L2, and then we're looking at next index, or partition. So we add this number to the second sum, then we're going to look at the next, right? So because we need to use this nums I in either the first part or the second part, there's no factor like partition L1, L2, I plus 1. So with that said, that's about it for the main hyperfunction. So now we are ready to make a return. First, we're going to check if the total is an even number or not, right? If it's even number, so we call the partition function. Otherwise, we directly return false. So I'm going to call the partition function starting from 0, 0, and also from index 0 if total over 2 is 0. Or let's see, total modulo 2 equals 0. Otherwise, we're going to return false. So that's the full code for this problem. So let's do a special case check first. Yeah, it passes the example 1 here. Now I guess let's do a generic case check. It passes the generic case. I guess that's about it for this problem. So essentially a rework of Leetcode problem 473. That's about it. Thank you very much.